Continue on Chapter 5, Functions and Graph. These are the learning outcomes for these subtopics.
Relationship between graph of f and f inverse. In this lesson, we will find inverse using graphical approach. Note that the graph of fx and f inverse are symmetric with respect to the line y equal to x. Consider the graph below. Fx as a straight line. Let's say fx start at negative a and y-intercept is b. Then we have line y equal to x here. Then f inverse is the reflection of fx at line y equal to x. And this is f inverse. Fx cross x-axis at negative a, so f inverse will cross y-axis at negative. The distance between fx and y equal to x is the same as y equal to x to f inverse. And then fx cross y-axis at b, so f inverse will cross x-axis at b. So this is the graph of f and f inverse. Consider the second graph fx. F inverse is the reflection of fx at y equal to x. So this is y equal to x. Let's say the graph of fx start at negative a, then cross at b. F inverse will also cross y-axis at negative a and cross x-axis at b. This is f inverse. This is the relationship between f and f inverse.
Example, find the inverse of fx equal to square root x plus 1 for x greater or equal to negative 1, and sketch the graph of the function and the inverse. To find the inverse function, we'll use the properties f of f inverse equal to x. F is now square root, x is f inverse of x plus 1 equal to x. Simplify, f inverse plus 1 equal to x squared, so f inverse equal to x squared minus 1. Then sketch the graph of the function and the inverse. To sketch the graph fx, square root, we need shape. Shape is positive square root positive x, so above and to the right. And second starting point, x plus 1 equal to 0, so x equal negative 1. And constant is 0, so starting point is at negative 1, 0 here included. And then sketch graph, negative 1 to infinity. And this graph has y-intercept at x equal to 0. For x equal to 0, y equal to square root 0 plus 1. So square root 1. Square root 1 is 1. Label the graph fx. The inverse function is reflection of fx at y equal to x. So y equal to x is here. This is line y equal to x. And then the inverse function is here. Start at negative 1, so inverse also start at negative 1. And then included, inverse also included, so this is f inverse of x. F and f inverse will cross y equal to x at one point. Next example, for each of the function below, find the inverse function and state the domain and range of f inverse. Sketch the graph of f and f inverse on the same axis. So for a, fx equal to negative x squared plus 5 for x greater or equal 0. Find the inverse function using properties f of f inverse equal to x. Negative x is f inverse square plus 5 equal to x. And then f inverse square x minus 5 over negative 1. F inverse equal to 5 minus x square root. State domain and range of f inverse. So domain and range of f inverse. Domain of f inverse equal to range of f. And range of f inverse equal to domain of f. Domain of f is x greater than 0. So range of f is also x greater than 0. And then range of f, since fx is quadratic negative x squared plus 5, so range of f is negative infinity up to constant 5 included. Sketch the graph of f and f inverse on the same axis. F is from 0 to infinity. When x equal to 0, y equal to 5. And then fx is negative x squared, so 5 included, going down. Label the graph fx. Cross x-axis at square root 5. F inverse is reflection of fx at y equal to x. Since fx start at 5, so f inverse also start at 5. And then included. Then fx start from 5 and going towards negative 1. So f inverse will start at 5 and going toward negative x. This is f inverse. Cross y-axis at square root 5. Next example, fx equal to square root x minus 2 for x greater or equal to f of f inverse equal to x. F is square root, x is f inverse, minus 2 equal to x. So f inverse minus 2 equal to x squared. And then f inverse equal to x squared plus 2. Domain of f inverse equal to range of f, which is constant. For function is 0, so range is start from 0, x positive, so infinity. And then range of f inverse equal to domain of f, x greater or equal to, so 2 to infinity. Sketch graph of f and f inverse. F start at 2 and positive value. 2 is included, so then circle. X positive, square root positive to the right. So this is fx. Then f inverse is reflection of fx at y equal to x. Since fx start at 2, so f inverse also start at 2 included. Fx going toward positive x, so f inverse going towards positive y. This is f inverse. So f inverse is reflection of fx at y equal to x. Last example, fx equal to 2 plus square root 4 minus x for x less than or equal 4. So f of f inverse equal to x. 2 plus square root 4 minus f inverse equal to x. Square root 4 minus f inverse equal to x minus 2. 4 minus f inverse x equal to x minus 2 square. And then f inverse equal to 4 minus x minus 2 square. Domain of f inverse equal to range of f equal to, constant is 2, so range is 2 to infinity. And then range of f inverse equal to domain of f, x less than or equal 4. So negative infinity to 4 included. Sketch graph. Fx is square root function, positive square root negative x, so above and to the left towards negative x. And the starting point 4 minus x equal to 0, so x equal 4 and y equal to 2. 4, 2. Starting point is here. And then above and to the right. Cross y-axis at x equal to 0. When x equal to 0, fx equal to 2 plus square root 4, which is 4. Label the graph, this is fx. And then f inverse is reflection of fx at y equal to x. So f inverse equal to 2, 4. Label the graph, f inverse x. And the intersection point must be at y equal to x. Next example, question 4, given that fx equal to ln x minus 3 and gx equal to 4x minus 9, sketch the graph of f and explain why the inverse function f inverse exists. So fx is ln x minus 3. First we have shape ln positive x positive. And second asymptote x minus 3 equal to 0, x equal to 3. Third, sketch graph. Sketch graph, asymptote is at x equal to 3. Yeah. function is from below, close to asymptote and to the right. This is fx. We know that inverse function exists when graph is 1-to-1. So check whether this graph is 1-to-1 function using horizontal line test. Since horizontal line test cut at 1 point, so fx is 1-to-1 function. F inverse exists when function is 1-to-1. B. Find f inverse and states its domain and range. To find f inverse, we'll use formula f of f inverse equal to x. F is ln x is now f inverse minus 3 equal to x. F inverse x minus 3 equal to e power of x. F inverse equal to e power of x plus 3. State its domain and range. So domain for f inverse e power of x. X is the power of e, so x can take value. Domain of f inverse equal to negative infinity to infinity. Range of f inverse equal to the asymptote of ex, which is 3, and e positive x positive, so to infinity. C. Show the relationship of f and f inverse on a diagram. Sketch the graph of fx and f inverse on a diagram. Asymptote is at x equal to 3. Fx from asymptote positive, so this is fx. And fx cross x exists at y equal to 0. Y equal to 0 ln x minus 3 equal to 0. X minus 3 equal e power of 0, x equal to 4. So this is 4. And then f inverse is the reflection of f, y equal to x. So f inverse will have asymptote at y equal to 3 from asymptote towards positive x, so here. So this is f inverse. And cross at, since this is 4, so this will also be 4. F and f inverse is reflection of each other at y equal to x. And then find g of f inverse and sketch the graph of g of f inverse. So we have f inverse equal to ex plus 3 and g is 4x minus 9. So g of f inverse equal to g f inverse. F inverse is ex plus 3. G is 4, x is ex plus 3 minus 9. Simplify. 4ex plus 12 minus 9 equal to 4ex plus 3. Sketch the graph of y equal to g of f inverse. Sketch a graph for index. So we'll have shape x positive, e positive, so from left to right. Second, asymptote. Asymptote is the constant, y equal to 3. And then third, sketch graph. Y equal to 3 is here. And graph is left to right. So this is g of f inverse. Y-intercept, when x equal to 0, y equal 4e, x is now 0 plus 3. 4 times 1 plus 3 equal to 7. So intersection is 7. And this is the graph for g of f inverse. Next question, given that fx equal to ln x minus 2, show that f is 1-to-1 function. F is a 1-to-1 function when x1 equal to fx2. So ln x1 minus 2 equal to ln x2 minus 2. Then simplify, ln and ln cancel out. X1 minus 2 equal to x2 minus 2. 2 and 2 cancel out, x1 equal to x2. Since x1 equal to x2, so fx is 1-to-1 function. B. Find F inverse. We have f of F inverse equal to x. Fx is ln x is F inverse minus 2 equal to x. So F inverse minus 2 equal to e power of x. F inverse equal to e power of x plus 2. State the domain and range for both the function f and F inverse. Since domain of f equal to range of F inverse, then range of f equal to domain of F inverse. So fx equal to ln x minus 2, domain of f is from asymptote x minus 2 equal to 0, so 2 to infinity. And then range is from function of ln negative infinity to infinity. Sketch the graph of f and F inverse on the same axis. Ln positive x positive from above to the right. Second asymptote x minus 2 equal to 0, so x equal to 2. Then third sketch graph, x equal to 2 is here, positive x from asymptote to positive x. So this is fx. And then fx has x-intercept at y equal to 0. When y equal to 0, ln x minus 2 equal to 0. X minus 2 equal to e power of 0, x equal 3. F inverse is the reflection of fx at y equal to x. F inverse will also has asymptote at y equal to 2 from asymptote negative x to positive y. Label the graph F inverse. Don't forget the intercepts. Fx cross x-axis at x equal to 3, so F inverse will also cross y-axis at x equal to 3. These are the graph of f and F inverse on the same axis. Last example, the function h and k are defined as hx equal to x squared minus 2, x is integers, and kx equal to log x base 2 for x greater than 1. A. Find K inverse. To find K inverse, use the property f of F inverse equal to x. For this example, f is now k. So k is log base 2, x is now K inverse equal to x. And then simplify K inverse x equal to base of log will be base of index 2 power of x. Then find h of K inverse. H of K inverse equal to h of K inverse. And then K inverse is 2 power of x. H is x squared. X is now 2 power of x minus 2. C. Determine the domain of K inverse. Since K inverse of x equal to 2 power of x, so domain of K inverse equal to x is the index of 2, so x can take value from negative infinity to infinity. And range of K inverse equal to domain of K. So domain of K x greater than 1 means range of K inverse also x greater than 1. So 1 to infinity. Then on the same axis, sketch the graph of K and K inverse. Kx equal to log x base 2 for x greater than 1. So to sketch graph of log, first we need to know the shape. Log positive x positive, so from above to the right. Second is asymptote. Asymptote is x equal to 0. Third, sketch graph. Asymptote is at x equal to 0. Yeah. Graph is close to asymptote and to the right, so here. And problem is kx has domain x greater than 1. When x equal to 1, y equal to log 1 base 2 equal to 0. Means graph start at 1 here and not included, so circle above to the right. So this is the graph of kx. K inverse is the reflection of Kx at line y equal to x. Since Kx start at 1 means K inverse also start at 1, not included. And then Kx towards positive x, so K inverse is toward positive y. This is K inverse of x. And K inverse also has asymptote at y equal to 0. And K inverse also has an asymptote at y equal to 0. These are your exercises. Please submit the exercises at the end of lecture.